We tend to imagine that modern submarines and robots have fully mapped the Mariana Trench. But the truth is far stranger. Over 80% of the ocean remains unmapped, and only 3 manned descents have ever reached the deepest point. So why the gap between belief and reality? Consider this. The Mariana Trench plunges to 11,034 meters, deeper than Mount Everest is tall. Pressure there exceeds 100 atmospheres, enough to crush most submersibles like tin cans. Yet despite these extremes, we've barely begun to explore it. The first manned dive, Trieste, in 1960, spent just 20 minutes on the bottom. Since then, only 2 more humans have repeated the journey. We've sent more people to the moon than to the deepest point on Earth. So what exactly is the Mariana Trench? It's a crescent-shaped scar on the ocean floor, stretching over 2,500 kilometers near Guam. At its deepest point, the Challenger Deep, it plunges nearly 11 kilometers down, deeper than Mount Everest is tall. The pressure there exceeds 100 atmospheres, enough to crush a submarine like a tin can. But depth alone doesn't explain the challenge. The trench is perpetually dark, with temperatures hovering just above freezing. Sunlight never reaches these depths, and nutrients are scarce. It's a world of extremes, where most life must adapt to crushing pressure and near-total isolation from the surface world. These conditions make exploration incredibly difficult. Submersibles must withstand pressures that would collapse any ordinary vessel. The cold drains batteries, and the darkness limits visibility. As oceanographers often say, we know more about the surface of Mars than we do about the bottom of the ocean. Yet, despite these hurdles, each dive reveals something new. So, how many times have humans actually visited the deepest point on Earth? The answer might surprise you. Since the first descent in 1960, only 3 manned missions have reached the Challenger Deep. The first was the Trieste, a Swiss-designed bathyscaphe that carried 2 men to 11,034 meters in 1960. They spent just 20 minutes on the bottom, raising a cloud of silt that obscured any view of the trench's secrets. It would be 52 years before another human returned. In 2012, filmmaker James Cameron piloted the deep-sea Challenger, spending about 3 hours exploring the bottom. His solo dive captured the first high-definition video of the abyss. Then in 2019, Victor Vescovo's limiting factor made 4 dives in just over a week. That's more visits in one expedition than in the previous 59 years combined. Yet even today, the cumulative time spent at the Challenger Deep is less than a single day. So, if the trench is so hostile, what kind of life could possibly survive there? The answer is more than you might expect. Each dive has revealed a menagerie of strange creatures, adapted to pressures that would crush any surface dweller. Take the Mariana snailfish, for example. Discovered in 2014, it holds the record for the deepest living fish ever found, at 8,178 meters. Its gelatinous body lacks a swim bladder, allowing it to withstand the crushing pressure without imploding. But the real surprise lies in the microbes. Scientists have found bacteria in the trench that can break down hydrocarbons, the same compounds found in oil spills. These extremophiles hint at the trench's potential as a source of new biochemical tools. Yet, for all these discoveries, we have barely scratched the surface. Each dive uncovers new species, but the Hadal Zone remains the least explored habitat on Earth. With less than 0.2% of the seafloor mapped, this abyss still holds countless secrets. So, after decades of exploration, what did we find at the bottom of the deepest ocean trench? What did we find at the bottom of the Mariana Trench? Not just strange creatures, but something far more unsettling, evidence of our own pollution, thousands of kilometers from land. In 2019, a research team discovered a plastic bag and candy wrappers at 10,198 meters, deeper than any human had ever walked. As Dr. Lucy Woodall put it, "We found plastic at the deepest point on Earth. That was shocking." In 2019, a research team discovered a plastic bag and candy wrappers at 10,898 meters, deeper than any human had ever walked. As Dr. Lucy Woodall put it, "We found plastic at the deepest point on Earth. That was shocking." But the plastic was just the beginning. A 2021 study revealed that amphipods living in the trench contained high levels of persistent organic pollutants, toxic chemicals that accumulate up the food chain, even here in the most remote place on Earth. So why, after all these decades, have we visited the Challenger Deep fewer times than we've landed on the Moon? The answer lies in a trio of obstacles: pressure, cost, and a simple lack of maps. The pressure alone is a showstopper. At 11 kilometers down, it's over 1 to 100 atmospheres, enough to crush any conventional submersible. Building a vessel that can withstand that force is astronomically expensive, with each deep-sea mission costing millions. Consider the experience of Victor Vescovo, who piloted the limiting factor. Even with a state-of-the-art submersible, his team spent months planning each dive, relying on sonar maps that were often decades old. Over 80% of the ocean floor remains unmapped, and the Hadal Zone, the deepest E0. 2% of the seafloor is virtually uncharted. The gap between what we assume and what we know is vast. What lies in wait just beyond our reach? Each new dive reveals organisms with enzymes that could revolutionize medicine and microbes that hint at life's very limits. As NASA's Astrobiology Institute puts it, the Mariana Trench is a natural laboratory for studying life under extreme conditions. But here's the thing: even the few dives we've made have barely scratched the surface. The trench stretches over 2,500 kilometers, yet we've only explored a tiny fraction of its length. Imagine trying to understand a continent by visiting just one beach. And pressure isn't just a barrier for machines, it affects life itself. At those depths, proteins and cell membranes must be specially adapted to avoid being crushed. This is why the creatures we find are so bizarre, with gelatinous bodies and unique biochemistry. Yet despite these challenges, life thrives. In 2018, scientists discovered a new species of snailfish at 8,278 meters, the deepest fish ever recorded. Its body lacks scales and a swim bladder, relying on a gelatinous structure to withstand the pressure. But the most resilient life might be microscopic. In 2020, researchers found bacteria in the trench that can survive pressures equivalent to 1,000 elephants standing on a postage stamp. These extremophiles could hold the key to new antibiotics or industrial enzymes, which brings us back to the plastic. That bag and those wrappers weren't just litter. They were a sign that our impact reaches even the most remote places. Microplastics have since been found in the guts of trench-dwelling amphipods, proving that no ecosystem is truly isolated. So why aren't we going back more often? The limiting factor: the only submersible capable of repeated dives cost over $37 million to build. Each mission requires a support ship, a crew, and months of planning. It's a price tag that limits exploration to a handful of wealthy individuals and institutions. But there's hope. New technologies like autonomous underwater vehicles and sonar mapping are making deep-sea exploration more accessible. The Seabed 2030 project aims to map the entire ocean floor by 2030. If successful, we might finally see what the deepest ocean trench truly holds. But new technology is changing the game. Autonomous underwater vehicles, or AUVs, can now dive to hadal depths without a human pilot. They map the seafloor in high resolution, revealing features we never knew existed. And these robots aren't just mapping, they're sampling. In 2022, an AUV collected sediment from 10,000 meters containing microbes never seen before. Some produce enzymes that could break down plastic waste, offering a solution to the pollution we've already found. And yet, we've visited the Challenger Deep fewer times than we've landed on the moon. The trench's secrets await, but only if we choose to look. The ocean's greatest mystery lies not in what we've found, but in what we haven't, and that should inspire us to explore further.